settings to go from 0 to 30. So at this day of the month, the average value that I found and the actual value were equal at that moment in time, right? So you can see it started off with a lot of clippings, and the clippings are decaying over the course of the month. And so since there was a lot of clippings here and then fewer clippings here, they average out to make this average value. But on one day of the month, actual amount of clippings in the bin equaled the average amount in the bin, and that's what we're looking for. So we're going to analyze the graph to the point of intersection. And it happened a little past the 12th day of the month, 12.415. So A of t equals the average value. A of t was equal to the average value of A of t when t was 12.4158. This is worth 2 points. 1 point for knowing how to find average value, and 1 point for the answer. Hello? I'm about to finish up my AP review in just a minute. Yeah, no, we're doing one last problem. Oh, y'all are done? Okay. Guess the weather wasn't good for a car wash. I don't know. Oh, he's mad because only other coach showed up and he left. The booster club, the football booster club, was having a car wash today, and he was annoyed because he's like one of the only people that showed up, and the only other person that showed up was the head coach, but he left like a while ago. So he's like, I'm getting a car wash and I'm going home. Okay, so that was worth 2 points, right? So you can see like none of the math on any of this is all that hard. It's just knowing what to do on this one. Now part D is worth 4 points. Alright, so part D says for t greater than 30, L of t, the linear approximation to A at t equals 30. Alright, so that's the tricky part of this, is understanding what that is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 0.5 pound of grass clippings remaining in the bin. Show the work that leads to your answer. So before we can use L of t, we need to find L of t. So we gotta know what that means. So the linear approximation to A at 30 means the tangent line to A at 30. We got to write an equation for the tangent line, right, is what this amounts to. And so remember, to write the equation for tangent line, we're going to do point slope, right, which means we need a point and the slope. So we know we're talking about when t is 30, or when x is 30. So the first thing I need to do is find A of 30, so that I'll know what the y value is. And then I need to find A prime of 30, so I'll know what the slope is, right? So to get the y value, we have to do A of 30. To get the slope, we have to do the derivative of A at 30. We can do both of those things on a calculator. The x is 30. So A of 30, I'm just going to do F1 of 30 in my calculator. It's 0.783. Alright, so I'm going to go ahead and store that just to be safe. I don't know if I'm going to need it again in a minute. I'll store it as C, I guess. I don't know what all variables I'm going to store it as. You can clear your variables if you ever need to, if you've got too much stuff. It's menu 1.4 instead of menu 1.5, I think. So I'll go ahead and store that. Then the slope would be the derivative. So menu, calculus, and numerical derivative at 30. That's F1 of x. Negative 0.056, which I will also store on the store as D. Oh, I forgot to store the other one. So here's my L of t equation. So y minus 0.783 equals negative 0.056 times x minus 30. Alright, so that's my L of t. So we're going to use L of t to predict the time at which there will be 0.5 pound of grass. Put these in the bin. Alright, so what I'm going to do is I'm going to solve this for y. I'm going to get the y by itself, and I'm going to put this in my calculator in y equals. And I'm going to put 0.5, and I'm going to look for where they intersect. So kind of like what we did on the other part of the problem. We're going to look and see, just like we did on part C, or part B, no, part C, where we graphed A of t and looked for where it equaled the average value. We're going to graph our L of t, our linear approximation, and look for where it equals 0.5. So all you got to do is move the 0.783 over here. That'll be solved for y. And when I put it in the calculator, I'm going to put D for the slope. I'm going to put C for the M here. I mean for the y intercept here. So go to my calculator. Go ahead and clear this out. This is the last part. Delete all. So y equals D times x minus 30 plus C. And then 0.5. And I need to change my window because remember this is starting at 30. So I'm going to go from 30 to 60. I'm going to change my window. Change my line. Where is it? Trying to think of the problem. That doesn't make any sense. Is y'all letting me graph it with the variables? Oh, I know what I might have to do. I might have to put D times. It's weird about meeting. That's what it is. Alright, so it was giving me an error because I didn't put a time sign between my D and my, I don't know if it did that to you, but it was giving me an error when I just typed in. So I had typed this in, I typed in D parentheses x minus 30 plus C, and it wouldn't graph it. It made me put a time sign in between here. I don't know why. And then it would graph it. Doesn't make any sense, but hopefully that doesn't happen. If it does, just kind of play around with how it's entered. It's done that to me before where it made me put a time sign. I don't know why. I might get the parentheses time. Alright, so analyze graph, intersection, 35.054 days. Alright, so that would be when it's at approximately 0.5 pounds. Exactly. No kidding. So this part is actually worth 4 points. With 2 points for writing the equation for the L of t. So 2 points for this slope-intercept equation. Okay. Then it was 1 point for knowing that you needed to set L of t equal to 0.5, and 1 point for the answer, 35.054. Right. So we are looking for where this equation, right, where does this equal 0.5? Right. And it was at 35.54 days. Sorry, that one took me a minute because I couldn't get my calculator to populate. Alright, so it was 1 point for using the slope formula, 2 points for finding and interpreting a derivative in the calculator, 2 points for finding average value and setting it equal to our function, graphing it in the calculator, and then 4 of the points for this last part. So 2 points for writing the slope-intercept equation, 1 point for setting it equal to 0.5, and 1 point for finding the answer. Okay. So like I said, I'm going to stay after Monday, Tuesday, and Wednesday this week. So if you have questions and stuff, look over some of the other multiple choice